Yeah, okay, so I put all the materials here in this GitHub repository. I put the link in the live chat if you wanted to just follow along. Otherwise, you can I'm going to show you the tutorial that I have. So what I'm going to discuss for today is I put together a very quick tutorial on how to use NLDI and water data to do a flow accumulation based on the vector flow lines using the NHDPlus database. So just a quick introduction. I know that you've been hearing a lot about web services, so I'm not going to go too much into the details, but just wanted to say that I wanted to just kind of show what was my motivation for creating hydro data, and then the things that I started adding, and it's kind of I'm adding more and more services. So the reason was that I had a hydrology course a year ago, and then we were tasked with doing some kind of processing data with the USGS data. And then when we had to go through all the websites, the USGS website, and then when you want to download, you have to do lots of clicks and just to get one for one specific USGS website, and then you have to repeat everything. So it was kind of a really long process. But so I started digging around, trying to see what are the best ways to kind of utilize the available services, because I assumed that USGS being like a really big public entity, then they would for sure have some services that they can offer. So when I dug around, I found this really amazing. I remember the first time that I saw this webpage, I was really excited.
Hey, Taher,
yep.
Can I interrupt and just ask you to tell us, who are you?
Oh,
very brief introduction.
Yeah, sorry. So I'm a PhD student at the University of Houston. This is my third year, and I've been working on urban hydrology for the past year. And most of my work kind of deals with working with databases from different sources, like land cover, land use. So because I'm most interested in urban areas, that's one of the reasons that I'm kind of interested in kind of data, is that most of my work relies on the data, and then I use this input data to work with the kind of models that I develop. So sorry, I totally forgot about introducing myself.
Thank you. Thank you.
Yeah. So yeah, as I was saying, that the first time that I saw this kind of webpage, it was really an amazing experience for me, because with just a couple of lines of, we just hit the generate button at the bottom of this page, and you can get the data that you like. So I started digging around and found a couple of really interesting web services. So I know that you've been familiar with web services. I'm not going to go into the details of it, but I'm just going to discuss the things that I've covered in the hydro data. So I'm using 3 web services. Essentially, hydro data supports 3 web services. One of them is RESTful, which is kind of a really, it has a general definition, but it mostly related to kind of textual data. When you want to have web services based on textual data, then you can do it with RESTful. But as I said, it's a very general definition. But for the purposes of kind of geospatial data, more specifically, there are 2 web services. One is WMS, which is for raster data. If you're interested in database with raster data, that you would go with WMS, and then WFS, which is mostly again for textual data, geospatial data in form of vector data. So these are the 2 web services that most of the time, most of the kind of packages that are included in hydro data rely on these 2 web services. And then there are a couple of pros and cons when you want to totally rely on web services for doing kind of the hydrology work. The pros is that it's really easy to access many of the databases that are available, and you don't have to kind of worry about doing some of the many pre-processing tasks using many of the a common pre-processing task. On the server side, for example, when you want to work with DEM models, there are some, like when you want to figure out what is the slope. So the source data are the DEMs, and then you're going to do lots of things with the DEM data to get a slope and then aspects and these kind of things. Then everything will be done on the server side. So most of the pre-processing will be done there. It will be easy for you to just extract the data and then filter the data that you need and get the exact values that you want. So it kind of really helps with automating and then all these kind of pre-processing steps. And then what are the cons is that because you're relying on services from other people, and they are really, like, for example, USGS, they are very a big kind of service. And then if there are some problems with the server, then you're going to be stuck with, for example, one of the issues that I have right now with one of the packages is with the elevation or Pi3DP that relies on 3DP program. And as you can see, the service has been down since last week. And I've been trying to contact them but haven't gotten a response. So you said the service is down. So essentially, I cannot use Pi3DP at this stage. So these are one of the downsides is that if there's a problem on the server side, then there's not much that really can do. And the other problem is that there are differences in implementation. Although there is OGC that tries to make it kind of a standard way of setting up the server and sending requests, but still there are some differences between ArcGIS and the way that OGC kind of does this up. So if you're not kind of very into trying to figure out what are the differences between the two, if you want to do the coding yourself, then it's going to be very sometimes frustrating. So that was one of the reasons that also that I have Hydrodata, just trying to create some easy API to access some of the most kind of popular web services. So just, I know that Emilio introduced the Hydrodata before. I'm just going to go over it very quickly. So Hydrodata offers is a Python, a stack of Python libraries that you can kind of pick and choose depending on your need. But for now, it only kind of includes only the data within the US. And then you can access raster data and also some geospatial, the vector data or in forms of a geodata frames from many of the web services that I'm going to discuss shortly. But then there are some limitations with, for example, with WMS and also with WMS and some of the RESTful services is that for each query that you want to kind of send, then there are some limitations. For example, for WMS, if the area of the raster file is more than, in some of the services, 80 million pixels, then the server is not going to kind of be responsive and it return an error. So under the hood, Hydrodata takes care of domain decomposition in case of a WMS. So if you have, like, for example, 12 million pixels, you request for 12 million pixels, then it's going to divide it into a couple of, for example, 2 domains of 8 million and then 4 million, and then it will download the data for the chunks and then merge them together later on. So on the user side, you won't have to deal with this kind of a splitting stuff. So you will get the data as you request for it. And the only limitation will be amount of available memory on your device. And then one of the most amazing services that I'm really interested in is using NHDPlus data. It's one of the things that I do for my own project. So I try to spend some time and then use some of the services that are available. And it's only, I added a week ago, I added support for high-res NHDPlus because previously it was only for middle-res data, but I added also support for high definition, high resolution data as well. And it offers some utilities for cleaning up the vector data that I'm going to demonstrate today as well. And then there is a repository of the URLs of the web services that I have tested, and I know that for sure it works with hydrodata. So these are the software stack that are included in hydrodata. The heart of hydrodata relies on these two, PyGeo OGC and then PyGeo utils, and the rest of the packages rely on these two to kind of provide a better interface or much easier interface to using these two databases. But if you want to go to lower level, and if you want to use some other services, you can utilize PyGeo OGC and utils. I'm not going to go into much details of it, but what I'm going to discuss today is just how you can use NLDI and water data to do a flow accumulation, of some of the properties that are included in science-based, USGS science-based catalog. So first, I'm just going to import some of the from PyNHD, NLDI, and water data. These are the two services that we are going to rely on. And the first thing that you always want to do is just to kind of instantiate an NLDI instance. And then first we want...
Taher, sorry for interrupting. I take my facilitation role seriously, or maybe too seriously. I suspect most people don't know what NLDI is. It's an amazing service that I don't think is widely known. I think it'd be helpful if you say a little bit about NLDI.
Sure, for sure, yeah. I've been working with, Dave is one of the people that are behind this NLDI service. So I've been working with him and then trying to kind of promote this package and then promote this service because it's really amazing, especially if you work with vector data and NHDPlus. This is one of the things that you would want to use later on. So the way that NLDI stands for Network Linked Data Index. So the way it works is that it's just going to hydrologically kind of link the available data sets. So for example, if you have like a network of data, this river network, then you want to know that if you're at this point, for example, what is the closest river network to this point? You give it a location, an X and Y, a coordinate, latitude and longitude, and then it's going to kind of snap you to the closest available river network. So then from then, NLDS also kind of gives you the option to navigate it, go towards, for example, if this is your point, then you want to know what are all the network upstream of this network. So because if you have worked with NHDPlus before, it's just if you want to do this manually, then it's going to be sometimes a really difficult task because there are some really complications if you want to do the navigation manually. But so NLDI takes care of this part of navigation under the hood, and then what you get at, you would give it a point, and then it would give you, for example, all the upstream flow lines, or if you want to know how many USGS stations are upstream of this point. Or for example, you want to say that at this point, go 100 kilometers upstream and give me all the USGS stations along the river network. So also it offers some of the things that I'm going to discuss later on in the course, but in the tutorial. But I would really I provided the link in the presentation. If you click on it, then you can hear. And there are some resources that are available. You can go into more details. But essentially, it's just the kind of heart of the service is that it gives you the ability to navigate the NHDPlus database. And then the water data is going to give you the ability to, it's a GeoServer. It's one of the, based on like OGC implementation of WFS and WMS. I only support these two at the moment. I'm not supporting WCS for now, but these two are the things that I support. And then if you, for example, go here, you will see what are the available services. You can get catchments, gauges, Hawk 18. So these are all the databases that are available in water data. So what I usually, the workflow that I have is I first use the NLDI to kind of navigate and find out all of the common identifier, COM IDs of the things that I'm interested in, and then I use these COM IDs to get the data from this water data, which is the thing that we are going to do in this tutorial. So after you instantiate an instance of NLDI, then we can do a navigation. So for example, let's say that we want to find all the tributaries of upstream of this USGS station. We want to see what are all the available flow lines. So you would have an F source, which is an NWIS site. Then what is the ID of this source? This is the USGS station. For example, this is what we're interested in. And then what is the type of navigation you want to do? For example, in this case, I want to upstream tributaries. There are 4 options: upstream tributaries, upstream main, downstream, and then downstream tributary, downstream main. So these are the 4 options that are available here. And then you want to say that this is my source, and then what kind of data sources? What is the data that you would like to know within this, that are available within NLDI? So then I'm interested to get all the flow lines. And then another option is to limit the distance. Just want to note something, that this distance, this operation as a whole is a very expensive kind of service request. So you have to be mindful of what value you would put here. So you want to kind of make sure that you don't put too much pressure on their server, and also the data that you would get interested in. So for example, in this case, I'm going to go with 1,000 kilometers. So the unit for distance is 1,000. So if you kind of pass these arguments here, it's just going to return all the flow lines for this upstream, or the tributaries upstream of this USGS station. And what I'm interested in is to kind of know what is the COM IDs. So in this here we are going to kind of figure out what are all of the common identifiers of the flow lines. And then we are going to use these COM IDs and use the water data GeoServer to get all the flow lines themselves. So it's going to kind of give you all the flow line, all the NHDPlus available data that are on NHDPlus, because NLDI is just going to give you common identifier, COM ID, and then the geometry of flow lines. But if you want to have access to other available attributes in database in the NHDPlus, then you have to use water data. So you just pass this COM IDs to the water data, because we want to use by ID here. And then this will give you kind of get all the flow lines. The next step is to now we want to see that what is the attribute that we want to do the flow accumulation. So probably a couple of weeks ago, NLDI released a new API and provided a very useful service that included in NLDI, and it's access to many of the attributes that are available here in this in science base of USGS catalog they can see here. So there are about 190 attributes, kind of additional attributes to NHDPlus. So and it's very useful. I really kind of use this. I've been using it for the past couple of weeks and playing around with it, and it's really a useful service. So I would really encourage you to kind of look through, see what are the available things. Maybe there are some things that you would be interested in. So, but the one that I use for this specific tutorial is to use the estimated mean annual groundwater recharge, which the data is available here. So essentially, I just looked through this and then found one of the things that I thought that would be interesting for this tutorial. Then what I'm going to do is that I'm going to find out what is the name. So the way that you can do it is that if you just kind of run this command after you instantiate NLDI, it's going to give you a list of all the available attributes, all the 190 attributes. So you can go through them one by one, or if it's easier for you, you can search for the database that you would like, and then kind of use this to get the data that you want. So in this specific tutorial, I went with the recharge. So you kind of give it what is the characteristic that you would like to download. Then you use this function get characteristic by ID. So all these characteristics in this catalog, everything that is here are based on COM IDs. So if you have COM IDs, you can have access to all the attributes, which we already have, which in each slide, we already kind of got all the COM IDs. So if you just pass the COM IDs, and then you want to say that I want to get all the local, so I will, if you want to later, I can explain what are the characteristic types. There are 3: local, divergence, and then total. But for now, I'm just not going to confuse you with many details. So you will get all the COM IDs, and then I want to get this characteristic. It usually takes a couple of minutes, so that's why I commented out these 2 lines, and then I just ran it once and then saved it as a Parquet file, which is one of the things that I usually use when I'm dealing with data frames. And then once you have it, so you can start playing around with it. So the first thing that we want to do is that if we want to kind of prepare the NHDPlus data for accumulation. One of the things that we need for accumulation is that we want to know that what is the, we want to source the flow lines based on topology, because we want to know what is the downstream, what is the upstream. So this function kind of takes care of that. It gives you, it adds 2 new flow, it adds 2 new columns. One is COM ID and then 2 COM ID, and it kind of gives you, it gives you an idea of, for example, which COM ID is upstream of the other COM ID. So it kind of topologically sorts all the flow lines in the database. So that what we want to do is that we want to kind of merge the characteristic that we downloaded from NLDI. And so this line is going to take care of the merging. We are going to merge it on COM ID because, as I've mentioned, the local database, the characteristic that we have is going to be based on COM IDs. And then once you have that, then you can do the merge, do the flow accumulation. So flow accumulation accepts kind of any function. It doesn't matter. So you can just use it. It's a generic function that you can pass. So in this case, because we want to do the accumulation, what we want, we have the recharge as Q, which is millimeter per year. Then we want to multiply it by the area, which is area in a square kilometer. So if you multiply this Q, which is millimeter per year, and then multiply it by the area, then you're going to get the kind of discharge for this specific flow line, for this specific catchment. Then you're going to do accumulation. For that, it's just going to take care of all the required things that you need to do for accumulation. Then the next step is that we want to also find what are the contributing areas for each of the kind of accumulated values that we have over here. So we're going to do accumulation once for the characteristic, and then once for the drainage area. Once you have these two, you just need to just divide it by the runoff. So this will give you the total runoff at the end. Then and the next is
Taher, can I stop you again? I'm sorry. My apologies. I should have said something at the beginning about how people could ask questions. I didn't tell you, Taher, how we would do that. Normally, we would have a Slack channel where people would be asking questions live, but I think it's confusing this time because this is the first time we actually had 3 parallel sessions. So if this is a good time with you, Taher, can we take a minute or two to see if people have questions? I think
sure.
you're presenting some great stuff, but also if people are not familiar with this kind of things, it can get complicated.
For sure.
Yeah, so I would say just speak up.
Yep. So does anyone have any question?
Or maybe my quick question is, which notebook shall I open to see these commands that you're using?
So the presentation is the one that have like everything that I'm showing here.
Yeah.
So at the end, I'm going to, if you want to follow along, as I've mentioned, if you just click on this binder, then it's just going to open up the something like up here. So we're just going to fire up.
At this point, though, given that we're halfway through, I don't recommend that in terms of following along, because it would take you a while to orient yourself.
Okay, thank you.
But it's fantastic to have that he has a binder there for you to follow up later. And I sent the link to his repository on the tutorials channel. So you can just go there and click it.
A quick question, Taher. Have you
Yes.
downloaded the DEM data that you're using here? I don't know if I missed that.
No, I'm not using any DEM yet. There is no DEM here. It's just this area is the drainage area, which is already included in when you get the data from water data. It has a drainage area included already in it. So if you look at the flow line itself later on, or maybe I can show it just now. Yeah, let me just kind of quickly flow lines. You see that it includes many data here. If I just do the columns, then you can see it includes like 193 kind of data here. So there's a lot of data already available here. And the one that I'm using is the area square kilometer. So which is going to, for each one of the com IDs, it's just going to give what is the drainage area for that, the area in a square kilometer. So that's what I'm using now.
Okay, so maybe to clarify my question, if you're, my understanding is if you're measuring the flow accumulation at certain points, you will need the DEM data that shows that I guess for some raster calculations, you would use it to measure the slope and the direction of flow. Is that what you're doing here? Is that
no. As of here in this function will take care of that. So what it's going to do is that here there is a com ID, and then there is a, let me just, probably it's better if I show it this way. And then a 2 com ID. So.
And if I may, while you're typing, I don't know if everyone is familiar with NHDPlus or what that is, but that's a product, a national product from USGS with Flow Network, the river flow network for the whole country, that in a sense already incorporates what you're describing. I forgot who was speaking, Ayman, I think, has already done all of that. So that's why Taher, what he's doing here, he doesn't need to do that directly. He's leveraging the work that has been done already.
Yeah, as Emily mentioned, these com IDs are already included, and there are some to-node and from-node available data on NHDPlus. But what this function does, this prepare NHDPlus, is going to use the com ID and then some of the available attributes in NHDPlus to find what is the to com ID. Essentially, it says that this com ID kind of moves toward this com ID. So this would be the upstream and this would be the downstream com ID. So this function is going to give you these two that you can use for kind of figuring out what is the direction of the flow. The direction would be from com ID to this com ID. So that's how I'm using this for doing the flow accumulation.
Okay,
did it answer your question?
Yeah, it does. Thank you.
Okay. So after doing the accumulation, we are going to get the catchment themselves, because all these attributes, this characteristic that we have is for at catchment scale. So we want to get all the catchments so we can use it for plotting the data. I'm just going to attach this for plotting purposes. Then this is the result before doing the accumulation. If you just plotted, this is the results. This is the available characteristic before doing the accumulation. This is a groundwater recharge that is available in all the catchments. So you can see what is all of them are millimeter per year. So you can see what are the ranges of data and the colors that are associated with it. Then if you do the accumulation, oops, sorry, go down. Yeah, if you do the accumulation, then this is what you will see, which is what we expect, that this is the upstream and this is the downstream. So once we did the accumulation, then it's going to kind of take care of, for example, from this, for example, in this case, we are going from this catchment to the lower catchment here, from upstream to downstream. So it's going to go from here before accumulation to here. So this flow accumulation is going to kind of move everything toward the downstream. So you're going to get, for example, if you're only interested in what happens in the downstream, then your last COM ID would be the one that you want to get at the outlet of your watershed. But you have access to all the available nodes here that you can use if you're interested in. So any question here? I'm going to move to just a very quick another topic. Okay. So just a very kind of simple thing here. I wanted to discuss what, since Py3DEM is not available at the moment, so I'm going to use open topography to get the data. I'm just going to quickly kind of show you how you can use the available tools in PyGeoCC and then PyGeoUtils to kind of do a manual kind of query from any service that you would like to use. So in this case, I'm going to fire up, I'm going to instantiate a retry session because we want to kind of query the data that we have. And then this is the URL of the service. If you go into open topography, you can find out what is the URL there. And then you want to say that what is the bounding box I want to get the DM data. Then you would use all the catchments. You would get the bounds. What is the like west, south, east, and north. And then afterwards, we want to kind of do it here. If you do the get URL and then payload, if you don't know what are these, just ask me a question and then I will let you know that what are these. I think maybe you've already dealt with this, so I'm not going to go into the details. So here, if you just do this session, start the session, you just do the payload with the URL, and then this gives you a response. So now you want to convert this response into an actual data set, into a kind of raster data set. So you can use in GeoUtils, there's this GTIF to X-array. It's just going to convert this response that you get into X-array. And one of the nice things about it is that if you pass it any sort of polygon to it, it's just going to mask the data based on the input, the polygon. Then this is the result that you would get. So here, I just wanted to get all the main streams instead of having, instead of getting the tributaries, I'm just going to get all the main channel in the database. And then I'm just going to mask the data that we downloaded. So this line here, this kind of cell is going to get the DEM data for the whole box. And then this function, this GTIF to X-array, is going to take care of the masking part. Because I passed it this mask here, it's just going to mask the data to this part that you need. So this is, for example, the data that you wanted to have. So the rest are kind of nans, all the kind of white ones are nans, and the data that you have are already here. So this is the one that I have. I included some other notebooks that you can play around with. Where did I put it? Yeah. If you go to the notebooks, I put some other notebooks here that you can kind of start playing around that. If you have any question, I would be happy to answer. But there are more examples of the capabilities of hydrodata and how you can utilize them for your own purposes.